Hello everyone. Let's discuss in this module the deviation in colligative property and the Van't Hoff factor. Let's begin with the first part, that is understanding what exactly is this deviation in colligative property, or what are the deviations from colligative property. Now what I say is there are three formulas which is there on the screen right now. They are of relative lowering of a pressure, elevation of boiling point and depression of freezing point. Let me talk about some macromolecules like proteins or polymers. When I talk about this macromolecules such as proteins or polymers, the thing which you should know is that macromolecules, they have huge molecular weight, they have high molecular weight. So the relative lowering of vapor pressure, the elevation of boiling point and the depression of freezing point, they all are precisely inversely proportional to the molar mass of the solute. So here I can say that for macromolecules where the molar mass is very high, the value of relative lowering of vapor pressure, elevation of boiling point and depression of freezing point is going to be very small, and hence it will be very difficult for us to measure. Then you must be wondering that why in this list of the formulas, why the osmotic pressure is not included. It's just because if you talk about osmosis, anyways the solute particle need to cross the semi-permeable membrane where I require huge solute particles. So for osmotic pressure I always require macromolecules, and if I consider macromolecules, then the osmotic pressure value where I will calculate the molar mass is always appreciable. Hence I say the osmotic pressure for such substance like the macromolecules are appreciable and can be easily measured. Also, hence for macromolecules, osmotic pressure method is the best method for finding out the molar mass of the solute. Let us try to understand the conditions for getting the accurate value of molar masses. The first one is the solute must be non-volatile. The second is the solution has to be dilute. And the third one, the solute should not undergo dissociation nor association in the solution. And if the solution or if the solute in the solution undergoes dissociation or association, then there is a deviation in the colligative property. So now we know the reason for deviation. The deviation is only when the solute is undergoing association or dissociation. Let's go and understand this in detail. Sometimes we know that the solute particle may exhibit association or dissociation inside the solution due to some of the intermolecular behavior. And whenever this undergoes association or dissociation, then obviously the number of particles are going to change. And if the number of particles are going to change, the colligative property is also going to change, because colligative properties are directly proportional to the number of particles. So now you will have two types of colligative property. One is that colligative property which you are expecting, and the other one is that colligative property which you are observing. Hence I can say one thing you will get is colligative property theoretical is directly proportional to n theoretical, that is number of moles theoretical, which I can also say that colligative property expected is directly proportional to number of moles expected. That is one thing only. Theoretical is as good as writing expected. But the other type which you can have is this: colligative property observed is directly proportional to n observed, or colligative property experimental is directly proportional to n experimental. So now you will have two types of colligative property when the solute undergoes association or dissociation. That is, either it has to be a colligative property theoretical or it has to be colligative property observed. And one thing is very clear: since the colligative property depends upon number of moles of the solute, these two values cannot be same, and hence I say colligative property observed is not equal to colligative property theoretical. And to make these two terms on the left hand side and right hand side equal, I will require a factor which is called as the Van't Hoff factor, which is given by a symbol I. So let's discuss this Van't Hoff factor in detail. One, we know that colligative property theoretical is directly proportional to n theoretical. This is the value which I am expecting. And the second one is colligative property observed is directly proportional to n observed. This is the actual value of colligative property which I am experiencing, which I am observing. So now if I take the ratio of colligative property observed upon colligative property theoretical, which is nothing but n observed upon n theoretical, then this ratio is going to give me I, that is Van't Hoff factor. And hence I say colligative property observed is equals to I into colligative property theoretical, and that is the relation of CP observed and CP theoretical, that CP observed is equals to I into CP theoretical for a electrolyte showing association or dissociation. Let's go in detail. Since I know that CP observed is equals to I into CP theoretical, correct, we have this four formulas now of four colligative properties. Let me take one in detail, that is delta TF observed is equals to I into delta TF theoretical, that is depression and freezing point observed and depression and freezing point theoretical, and to equal it I have a Van't Hoff factor I. Now delta TF theoretical is given by the formula Kf into small m, so I can say delta TF observed is equals to I bracket Kf into small m. So I have to multiply the right hand side by I. So what do I get? Delta TF is equals to I Kfm. It simply means that in each of the four cases I have to multiply by the Van't Hoff factor. The first one it is I, second one is I, and the last one is also I. So it simply means that whenever you are dealing with a solute which is undergoing association or dissociation, that is nothing but an electrolyte. These are the four formulas which you are supposed to use. First one, P01 minus Ps upon P01 is equals to I into X2. Second one, delta Tb is equals to I Kb into small m. Third one, delta Tf is equals to I Kf into small m. And last one, pi is equals to I CRT. That's all we have for this particular module. Thank you so much.